In a previous video, I talked about multiplying binomials. And the process, I'll just take you through this real quick, was that we would take our binomial here in parentheses, we'd take the first term and multiply that, distribute that in. So we had x squared plus 7x. And then we would take our second term and distribute that in. So we had 4x plus 28. And then we had these like terms in the middle that we could combine and give us 11x. But now I want to talk about how we go backwards. And this is actually a pretty easy strategy to come up with. The first thing I would do is I would always look at the last number, in this case 28. We sometimes call that the C value. We'll sometimes kind of generalize a little trinomial like this, where A is the coefficient for x squared, B is the coefficient for x, and C is the number that doesn't have an x with it. But that number 28 is the product of 4 and 7. It's just, 7 times 4 is 28. And 11 is the sum of 4 and 7. So if we're given a trinomial and asked to write it as the product of two binomials, we can use this idea. So let me start with this. This number here, 20. I need two numbers that multiply together to be 20. Let me write down the pairs that multiply together to be 20. 1 times 20, 2 times 10, and 4 times 5. Then I need to ask myself, which of those pairs adds up to be 9? So you can kind of go through, of course, 1 plus 20, 2 plus 10, 4 plus 5 will do it. That is the pair that will work, that will multiply to be 20 and add up to be 9. So my binomials are going to be x plus 4, x plus 5. Order here doesn't matter. Remember that multiplication is commutative, so if you put the 5 here and the 4 here, that's exactly the same. Let's do another one. All right, x squared plus 13x plus 30 can be factored into binomial multiplication. Again, I always start, and I would highly recommend starting with that last term and listing out the multiplication pairs. And I'll explain why. Let me write them down here real quick. And I'll explain why I would do that first. The reason I would do that instead of starting over here and saying, well, what numbers add up to 13 is an infinite number of numbers add up to 13. I can think of an infinite number of pairs. But there's a limited number of whole number factors that can do 30. But now go through which of these will add up to 13. And of course, there it is. 3 and 10 will add up to 13. So my factors are x plus 3 and x plus 10. Let's do another. Now, this one, it's a little bit different. Notice that I am subtracting here. So I'm going to just kind of ignore for a second that that's a subtraction, and I am once again just going to list my factors. So 1 times 16, 4 times 4, and 8 times 2. But one of these, since we have a negative, it has to either be 1 times negative 16 or negative 16 times 1. One of each of these pairs has to be negative because a negative times a positive is negative. So now I have to think, okay, how can I make 6 making one of these negative? Well, 1 minus 16, 16 minus 1 won't do it. 4 minus 4, 4 minus 4 won't do it. 8 minus 2 would give me 6. So if I'm going to add that here, it's going to be a negative 2. So I'm going to have x plus 8 and x minus 2, like that. So just adds a wrinkle there if you got a negative. Let's do another one. All right, so here I am back to having a positive value at the end without an x. But notice now I have a negative here. So let me list my pairs. I'm not going to do anything different. But think about the fact that this is positive means that either it's 1 times 4 or it's -1 times -4, since a negative times a negative would be positive. It's 2 times 2 or it's -2 times -2. Well, the fact that this is -5, there's no way that these pairs can both be positive. They must both be negative. So think -1 plus -4. That will do it. -1 plus -4 is -5. So I'm going to add, we're going to have 2 negatives here. So we're going to have x minus 1 and x minus 4. So be careful with your signs, but always start with that last number. List out your factors, list out your pairs that would multiply together, and then start worrying about, if it's a positive or a negative and how you're going to get it to add up to that coefficient of x. I want to, before ending this, just explain the reason we care to do this is that this form, this standard form, often will tell us the shape of the curve by the highest power and the y-intercept, what happens when x is 0. But this factored form tells us where the graph hits the x-axis. So both forms tell us something. So if we're asked to graph, it's really helpful to be able to jump between the two forms because we get the shape and intercept, y-intercept here, and we get the x-intercepts here. If this video helped you, please like and subscribe for more math help.